this presentation talks about extending, if David said that SONiC is going in new directions, and on the previous slide, presentation, we just showed how to add PoE, which is, let's call it a capability added to SONiC. Now we have a really interesting and innovative idea of going to a different use case, a different type of actual device, and not just a capability. So a few words on OpenLAN switching. So OpenLAN is part, also shortly called OLS, is part of the Telecom Infra Project, also called TIP, which is a global community working together to accelerate development and deployment of open and standard-based technology solutions. One of the subgroups inside is the Open Wi-Fi, and actually OLS uses the Open Wi-Fi foundation in order to create that solution, and we'll talk about it in the next slides. And the Open Wi-Fi was created in order to help move the industry into the new Wi-Fi capabilities and infrastructures. And the main idea behind the OLS is that behind every open Wi-Fi, you need a great PLVision switch. And we'll talk about it in the next slides. So I said that in the tip, the most important thing is community, and it's really all about teamwork. Because in order to get to that solution, we need collaboration from different companies doing different things. So in the silicon, we have Marvell, and I'm sure many other chips, that gives a chip that is actually target to the managed enterprise switches. We have hardware platforms by many vendors, and even more than written here, EdgeCore, Celestica, Windstorm, Arch, Larch, sorry. So a variety of hardware platforms that could work. Beyond that, we have collaboration with PLVision, who is doing, which is a software company focused on the open networking and doing the enhancement in SONiC. And in this specific use case, we have Shasta Cloud, which is doing the cloud network as a service and allows you to have management from the data center for your switches. Okay, so let's talk a little bit more about what OpenLAN switch is, what OpenLAN switching is, and what does it want to do. So I think the main purpose is to enable a more diverse and alternative way to wire closet switches. That means in order to support all the Wi-Fis that are going to be connected, you want to use PoE. And you don't need specific power connected to all those Wi-Fis. And we see a lot of use cases. We can see switches that are as small as 8 ports. And as we go into a higher scale, we can even get to 48 ports. And we need these switches to support not only existing Wi-Fi, which is 1 gig or 2.5 gig, but actually to go all the way to Wi-Fi 7, which is even 10 gig. So that's very interesting. And like I said, the PoE or PoE plus, which provides up to 25 watts, is also needed in order to power all those wireless switches. And from the feature set, they want to focus on layer 2, layer 3 features. Actually, it uses the same feature set that you have in the Wi-Fi itself, because the management is actually shared to the Wi-Fi and to the switch. It actually uses the same infrastructures. And I think one of the big challenges is how to make it open and how to validate it. So on the open, that's the reason we're all here. I think SONiC is also the way to go here, another really great use case that shows the strength of SONiC. There is a few missing pieces, like how to do secure zero-touch provisioning, open over public networks. I think Taras will explain that a bit in the next slides. And how to have a unified cloud management. Like I said, it's the same management for the wireless and the wired network components. And the validation of out-of-the-box is also needed, and I think that's where the TIP is going to help us, where you have a certificate done by the TIP organization. Okay, so we talked about using SONiC, but actually it's, like I said before, it's a totally new use case. So we have the cloud data center switch, and now we want to move into a campus switch. And these are the differences that we wanted to discuss because we think they're the most interesting here. So in the data center, the topology is repetitive, it's stable, it's organized, it's inside a trusted network. You have people which their job is to configure the data center, manage the data center. And on the campus side, on the other hand, it's very different because those boxes can get even shipped by mail and installed by an untrained person, right? It can be in a store, it can be in a place where there are no humans, right, for example. And so it's very different. How do you deploy it? And also the deployment options are very different. It's not repetitive like data center, but every store, every, I don't know, gas station can have a different topology you need to support. It's form management. This is, I think, a big difference. So you need to have a cloud management instead of, let's say, a pre-configured configuration that we see in the data center that you usually do once and you duplicate it across the switches. So here you want to allow remote access in order to manage those switches. So it's a data center. Another big difference we see, and I think that kind of relates to the previous question, is how the hardware looks. Because in the data center, like we said, it's high RAM, high storage, right? It's a multi-core, strong CPUs running the show. But when you go to the campus, it's much more cost sensitive, and you have lower memory, lower storage. But on the, let's call it on the plus side, also the requirements and the bandwidth is much lower, right? We're not talking about 50 plus terabits, right? We're talking about 300 gigabytes. So it's much less, and I think we have a great opportunity here. Okay, so this is, I think, a great example how it looks. And I want to talk about this picture because I think it's very interesting. As you can see in this picture, the heart of the system is the switch. So we have two types of switches in this case, 24 ports and 48 ports, who supports PoE+. PoE+ is used to connect all those endpoint devices like the Wi-Fi, okay, which requires power and networking services. It's also used to connect to certificate authority, the TIP certificate authority, and that's needed in order to connect to the data center management. It does that using the use central scheme, which is a scheme defined to manage the wireless devices. And above it, in the cloud, for example, you have the Shasta cloud, which has the, let's call it the client or the server side that connects to those switches, configures them, and display all the information. And Taras will show that as we go. And inside the switch, as you can see, we have on the hardware, we have the, for example, here the Marvell ASIC, and we have the PoE vendors coming in. Above it, we have the SONiC software with extensions done by PLVision. We have a certificate that will be used to do the connection to the data center. And we have the use central client, which is used to connect to also to the data center. So, sorry. So, two important things here is to have the zero-touch provisioning over the open network. This allows the cloud to identify the switch in a unique manner and make sure that it belongs to it, and it redirects it to the right data center controller. And the TIP certificate authority is also used in that process. And ongoing management is, that's what the data center or the cloud is doing, not data center. The cloud management is used for is to configure the switch, to read the status, to do telemetry readings, to do software updates. All that is supported by the cloud management. And once again, so some of these abilities exist today in the SONiC, and some of them are missing in the SONiC or in the SI. So we're in the process in the OpenLAN switching of adding those supports to the SI and the SONiC by PLVision mainly. Okay. Technical problems?
Maybe try this one.
No, it's no. Okay, so we already have a big number of devices that already support this solution. It's actually it's
not updated.
Oh, great. All right, let me retry that. Sorry about that.
It's not that one.
No, yeah, it's not that one. You're right. Okay, sorry about that. So like I said, we have multiple platforms already supporting this idea based on Marvell chips. We have AstroFusion, EdgeCore, Larch, Winston, and even additional vendors, right?
Yes.
Already implementing it. And it varies from connection to older Wi-Fi that support 1 gig and 2.5 gig, but it also is ready to go to like I said, Wi-Fi 7 doing 10 gig. Okay. Okay, so in the basis of all that, Marvell has created an optimized switch silicon for cloud management enterprise. It supports ports from 1 to 10 gig in order to support the new Wi-Fi, 6E and 7. It also has new features like inline MACsec. This can be used for IP cameras, for example, where you want to encode the data because it's private. So that's also supported. It has an integrated dual-core ARM CPU, which is used to run the SONiC based on the ARM platform. It has an integrated controller in order to write the PoE firmware, managing the PoE power. It has secure and trusted boot, so it's a secure device where you can deploy it in a remote location and it's secured. It has advanced features like tunneling and microsegmentation. Although, like I said before, are not yet all of them in the SONiC and the SI, but we're working on it. And it also has programmability for advanced telemetry. Sorry. So, like I said, it comes with the right cost. It has the right performance. It has all the network features needed and the future ones that may be needed. And it's customized for cloud management. Ars?
Yeah, and answering the question and following up what Guy was talking about, the enterprise environment, DC environment are completely different. They are the same, but the same case completely different. Why? First of all, it's cost. You are deploying thousands of switches data center globally. You are deploying millions of switches for the enterprises globally. It's the order of magnitude of 10, 100, depends how you count, but it's much, much bigger number of switches. You cannot allow the spendings you do within the data center to do it on your campus. It's just not feasible. So in order to make it happen, we have to make SONiC to be less. Okay, now we have the. No. Give me a second. So we need to make SONiC a bit lighter. So how we do it? I mean, we started to look, we at PLVision started to look at this maybe 2 years ago and started actually doing these things maybe a year and a half ago. And we were even given the talk about analyzing what's taking the most of the resources. And on today's presentation earlier, there was the talk how to make it less dependent on the resources. Simple, disabled features you don't need. We did it that we did disable Dockers that are not really needed in the enterprise environment, like Gearbox, NAT, S-Flow. That's, again, not rocket science. Additionally, obvious choice to move to the Slim-based containers as the baseline from the Docker. And it allows us to fit this sweet spot under the 4 gig of RAM running SONiC with the configuration applied, compared to the, I would say, at least 8 gig needed for the DC use case. But in order to run SONiC within the cloud environment, it's not just enough to make it tighter. There is a need to have the cloud management, and we need to add the cloud management. And I know we are, again, lazy enough, so same picture I was presenting in the previous presentation. I believe, okay, it's not that one. Come on. Why is that? Okay, same picture as we've seen in the previous presentation, but the name of the container is different. So same, SONiC is flexible to the way that you can do a new feature with a new container, and if you will try to present it, it will look exactly the same. So no rocket science here. The uCentral client as the new container being added to the SONiC. The main goal of the uCentral client is to take the certificate and use it to the secure connection to the cloud, take over the local SONiC ZTP to implement over the internet secure ZTP. It implements uCentral protocol, which is open source defined under the tip, Open Wi-Fi and OpenLAN Switching. And there is a link to the JSON-based schema of this protocol. And what's important part here is how we do the provisioning, because you can have the greatest switch, but if it's really hard to deploy it and manage it in the long run, it will be not efficient to use it. Hopefully, yes, great. So how zero-touch provisioning over the public internet works? So it's really, again, not rocket science. I believe it's obvious. When device is manufactured, each and every device is assigned the unique certificate from the certificate authority. That certificate is installed on the device by the vendor. Once client orders the devices, either from the vendor or from the distributors, the vendor or distributor relays this information to the cloud company, the cloud management company of the choice of the client. It can be Shasta Cloud, here as an example. There are several more, like NetExperience, Eurelio, and others. And this information is being stored within the TIP certificate authority. So each device has its own unique identification and the information to which cloud provider it should connect. Once device is arrived, connect it with any port, faceplate port, to the internet, and the device will start the secure ZTP process. It's simple. Connect to the TIP authority, request to which cloud it should connect, get this information, and connect to the cloud. Once connected, you can get the software upgrades, you can get your configuration, you can get the even factory reset or even the update the certificate. The protocol itself supports remote shell and the whole set of the configuration features available within the uCentral client. And to give you a bit of overview, how the cloud management works. Again, it's not rocket science. We've been seeing these management interfaces and management syncs done already in the local NMS, in the cloud NMS. So the idea here is to have the same functionality available for the enterprises as they used to, but utilizing the scalability of the cloud deployments. So on this screenshot that was provided by our friends from Shasta Cloud, we can see that we can configure the switch. We see the ports. We see the information about it, the picture of its deployment. Additionally, we can see like the standard thing we can expect: number of clients, number of flows, overall data being transferred, some alarms, etc. And as we said, enterprise deployments are different. So there is still a gap within the SONiC itself to support the whole set of use cases needed by the enterprises. The first one is PoE, and we are gladly collaborating with Marvell to push it to the SONiC. There are others like port security, Q&Q, MAC-based VLAN assignment, policy groups, flow management, telemetries, and these are still to go. We encourage the community to step in and help us do this. We do also work quite closely within the PANS group, and we are part of it, so to synchronize, because we do have the same goals here. And just as the summary, to give you why we are talking about this, because it sounds nice, but why? So this is the production-ready solution. So as of today, we have hundreds of thousands devices, Wi-Fi devices deployed already. We are reaching close to the thousands of switches being added and added more. 5 ODMs announced, up to the 60 different SKUs support this technology. So it's really in the state that it's ready to be deployed. So feel free to join and to deploy it, get back the feedback, what's still needed. And it's all based on the simple principles. There are several hardware vendors. Today we talked about one of them is Marvell. There are several hardware platforms from Celestica, Wistron, EdgeCore, and others. There is an optimized SONiC, which is the main part of that allows all this happened, because instead of relying on the proprietary system, which basically ties you to the roadmap of that proprietary vendor, you can now take it under your control and build it through the community management, as well as the cloud management. The SDK is open sourced. There are a number of companies providing these solutions, so you have a choice which one best for you, or build your own cloud management if it's applicable for you. And we're ready to get questions.
Praveen from Cisco. On the list of the features that you had listed there, the spanning tree, IGMP snooping, and a few others, multicast.
Yes.
Can you quickly talk about like where are they in terms of like, is this a ask to the community?
It's
or?
the ask.
Okay.
So what we've started is the spanning tree. It's I believe Broadcom did contribute at some point. It's in the shape that has to be refreshed, and I believe there was the discussion through the PANS that the companies Broadcom will join, and I believe it was XFlow, to introduce MSTP to the SONiC. So again, it's not something we are forking here. We are utilizing what's available in the community. PoE, ourselves and Marvell, pushing back to the community. Multicast, IGMP snooping, these I would say priority 2 features, and we are encouraging community, please step in and help us to build those, as well as others.
Thank you.
Good talk, Li Hua from Microsoft. So a question on the secure ZTP that you mentioned. So is this something that you can already do on the existing SONiC, yes, or is this something you have to customize SONiC for?
So, so the uCentral client itself, yeah, it's open sourced, available as the app extension to the SONiC, so we can freely install it. In order uCentral client to provide the secure ZTP, you need to have the certificate. So this is the only thing that is missing from the existing deployments to support this secure ZTP. So the device has to be identified in some way. Currently, we are working with the ODMs that pre-installed that. If you have existing deployments, there are talks currently to support other things of authentication, maybe some DHCP options when you already have the deployment available, but it's not yet finalized.
Okay, so what you install on with the manufacturer is what? It's a certificate, or
It's a certificate.
You mentioned Mac, so
It's a certificate. So each box comes with a certificate, and then the uCentral client, as the Docker, it mounts that partition to its own, and then reads the certificate and uses it to authenticate itself in the certificate authority as well in the cloud.
Okay, cool. Thanks.
It's Eddie from Alibaba. So you mentioned that you have the multicast, those Q-in-Q and the spanning tree, those features will be added. So those are not a typical like a data center features. So I want to see that on the one side, you say I want to reduce the image size, but those features, how do you want to introduce some kind of bundle feature, this kind of concept, or?
Again, great question. I believe that's the follow-up question from Dell. Yeah, the idea here is to work and define the different flavors of the SONiC when we're talking about the community. Different companies take the different approaches. So I do see some companies provide their own enterprise distribution that has those features already packaged. By the way, we are one of them. We do provide our distribution as well. But when I'm talking about the community here, so the idea is take the implementation that's currently available, implement it in a way, if something missing, implement, and to package it, I would say that what we would do is we are disabling the data center features which are not needed and replacing them with the XSTP, IGMP snooping, multicast, etc.
I think today that's one of the challenges that we have in the pens, right? Is how to, in the SONiC itself, how to enable or disable features. There are multiple ways to do it. Some of them are in the build system. There is the infrastructure with the Docker,
yes,
the
yes.
extendable
app extensions.
App extensions, which is also an interesting way. And I think one of the challenges we have today in the pens is really looking at the SONiC and asking ourselves, do we want to make some way, a formal and well-defined way, how to customize? Instead of each feature having its own bag of tricks, we want to look at all those abilities and come up with one suggestion that we hope will become the default standard. And then we can use that to create, I wouldn't call it flavors, but use like a profile-based approach that in that profile you will mark the features that you want, and those are the features that you will have in your specific image.
I believe that important part of this would be all of us to understand and define the baseline. So as of today, the baseline of SONiC is the DC use case, because it was only one use case. What we need to think about quite carefully, what is the baseline SONiC OS, just OS? And then you have the DC flavor, good, it's the same it was before. You have the telco flavor, cool. You have the enterprise flavor, cool. Flavor, profile, we can name it. But to agree what baseline is, this would be the main challenge for all of us, but the main achievement. And again, welcome to the PENS group or any other TIP group or OpenLAN Switching group. Reach out directly. Any contribution will be beneficial and help us.
All right. Okay. Yeah, we can take one last question.
Hello, Ryan from Arista. I was wondering, you had another diagram where there were APs as well, and I assume a lot of the APs are using OpenWRT or
Correct.
something like that. I'm curious how one would weigh moving these low-end edge switches to use OpenWRT versus moving APs to use SONiC down the line.
Issue with using SONiC for the APs, as of today, there is no much open source Wi-Fi stacks available. And Wi-Fi drivers, this is the issue. So there is, but again, I believe this is not that, maybe we can follow up, not to spend the time, because I can talk about.
I think the important thing is that they use the same management. They also have a uCentral component. And I think that's the most important thing, right? Because the underlay, at the end of the day, it's so different. You cannot, I think it'll be wrong for SONiC to go to that way,
yeah.
okay? And I know that OpenWRT had some kind of switch flavor where you can build a switch using it. Yeah. But we believe that the SONiC is the way to go. And also, when you look at the cloud management idea, I think it's a really strong idea because SONiC doesn't have all the elaborate CLI. It does have CLI, but it's not elaborate enough. It doesn't have a web-based interface. And when you look at putting all that knowledge and ability in the cloud and have like a GNMI interface that allows you to talk to it, really takes all that load from the SONiC system, which in these cases is already very busy, and putting it on the cloud, I think it's a really great idea, and I really believe in it.
Awesome. Thank you.
Thank you.
Thank you.